Right, question 16. Light of wavelength lambda is incident on a clean metal surface. Electrons are not emitted from the surface when the wavelength is longer than the threshold wavelength, lambda naught. Which equation enables the maximum velocity v of the electrons of mass m emitted from the surface to be calculated? Alright, so since energy is involved, the first step that we would try to do is HF equals to work function plus half mv squared, right? You look at all the options, they seem to always relate to half mv squared. So here we are not going to use EV on this part of the equation. Next, we see that they are giving their question in terms of wavelength. So the incoming energy can be rearranged to be hc over lambda. We know that the work function phi is given by hf naught, which is also given by hc over lambda naught. Right? This is the different forms of work function. Subbing that in, we get this straight away. Rearranging, we get half mv squared equals to hc over lambda minus hc over lambda naught. Right? And this jumps out at us because it seems that the answer is C. Right? Answer is C. Question number 17. Ooh, long way down. Number 17. Electrons can move from a higher energy level to a lower energy level, emitting a quantum of electromagnetic radiation, basically a photon. The diagram shows 5 energy levels in the photon and some transitions between them. So let's look at the transitions. We have 2 long transitions, which means high energy. One about 3/4 of the maximum and the other one about half. Okay, so we have 4 transitions. Since energy is equals to HF, if we look at just the frequency, right, we should have an increasing wavelength, right? Since it's increasing, if this is increasing frequency, we should have increasing energy, right? Increasing frequency, we should have increasing energy. So since the length of the line here, right, denotes the amount of energy, we should have 2 energy levels that are pretty close to each other, and the other 2 to be a little bit separated apart. So this seems that these 2 are correct, right? 2 of them that are of the highest energy, 2 at higher energy levels are pretty close together. So B and C are your options. Next, we have increasing wavelength. E is equals to hc over lambda. The higher the energy, the lower the wavelength. Since we have 2 wavelengths, 2 frequencies or 2 energies that are close to each other, when you inverse them, right? When you inverse them, the shorter wavelengths should also be closer to one another. Right? So this is correct. The shorter wavelengths, which correspond to high energy, should be close together. Right? These 2, we have 2 energy levels that are close together at the high side. The wavelengths on the low side should also be close together. So answer is C.